back everybody, my name is Dustin, and in the last video we ended up changing and getting the animation working and adjusting the jump. We also worked on the contact, and in this video we're going to actually start adding in the log display. So instead of logging everything to the console like this, we're going to have a new display that will log it in the editor. So it'll basically be the same thing as the console, but instead of using the console, we're going to have a new display. And then if we have time, we're also going to start adding projectiles. Well, we'll probably just save projectiles for the next video, okay? So yeah, so this video will add the log display, and the next video will add in the projectiles, okay? So right now, the way that we're doing our displays, if we just go to our displays here, let's close all this. We don't need all this. Actually, we can close all these tabs. And we can go to our editor, source, editor displays. And we only have our scene display right now, so we can open both of these. We're going to have to make a little change here. So right now we're just going to create each, but we're going to actually use polymorphism. So we're going to have to add in a interface for everything to inherit from. So we'll do that here. So go to displays, add new file, and it'll just be idisplay.h. Oh, this is new. Oh, really cool. I like this, whatever this change is. So cool, I like that. It's actually open up our that CMake file. Very cool. But we're going to take this, put that right here. So we have our eye display, and we're going to need a couple things here. We're going to need our pragma once, and then we're going to say include vector, include memory. Then have our namespace, Scion editor. And we'll have struct iDisplay. We'll have a virtual destructor. That can just be default. And we're only going to have one function for now, and that'll just be virtual void draw. Have that equal to 0. And we're going to make another struct. We're just going to call this struct display folder. Now this is all this is going to have is a vector shared point of a unique pointer, unique pointers of iDisplays. That way we can use polymorphism and just run through all the displays and call the draw function. So basically what we'll do is we'll just add the display holder to the registry, to the main registry, and then run through those displays. Okay. All right. So now that we have our nice interface, let's add that in here. Here we can just go include. Displays or iDisplay. And just go public iDisplay. Now this function was already in there, but we can go, just to make sure, we can go virtual override. Now we don't have to do that, but it allows us to know that we did make this change. So now that we have our iDisplay and we've adjusted our scene display, let's make a new one here, add new file, and we'll call this log display.h. Add it into our CMake. Log display.h. Pragma once. Then we're going to want to include iDisplay. Then we're going to want to include ImGui. Namespace. Sorry, ImGui.h. Scion editor. And we'll have our class log display, public I display. And for our log display, we're going to need to have some private variables. And the first private variable is going to be an ImGui text buffer. We'll call that m text buffer. We're going to need an im vector of int. It's going to be the text offsets. Then we need bool mb auto scroll. Now it's going to always auto scroll for now, but we'll have that option to change it later. Then we're going to have some private functions, and that's going to be void get logs. And then we'll have public. That's going to be log display. It's a constructor. And then the destructor can just be default. Then we're going to have another function, void clear. Now we want this one to be public because we may want to access it outside of the class itself. And then we're going to have our virtual void draw override. Cool. Let's see if it makes it correctly for us. All right. So it created it, but I had to restart it because it got frozen. So it didn't actually create any of these functions for us. So let's just copy all this for now. Copy, then go over here. And let's just go include in displays, log display. Say include. We're going to need the logger. And we're going to need ranges. That can be in this. Then we're going to say namespace. Okay, so before we can actually start working on this, we have to go and make some changes to our logger. So over here, Visual Studio X, funny sometimes. So you see how we have our log entries? We need to add in some ways to get these entries back to us, because I don't think we're doing that right now. No, we're not. So right here, we'll do it up here. Actually, no, we'll just do it down here. These together. And down here, we can have one called void clear logs. And we'll say, so right here, see how we have log added? We need a way to reset that. So we'll just say void reset log added. And that's just going to be mb log added is equal to false. Fine. And then we can say inline bool be const get log added. So is log added const return md log added. Cool. Then we also need one to get the logs. So we can do that here as well. And we can say inline const std vector of log entries. We want a reference. And we can say get logs. And that just be return log entries. Sorry, mlog entries. Yeah, clear logs could probably be inline as well. It's just mlog entries dot clear. All right, we're on our way. So now we have to go and make some changes to our logger.cpp and our .inl file. So in here, so every time if we're retaining logs, we need to come in here and say log added. So we'll just add that in. So mb log added equals true. Just copy that and put that everywhere. Down here, every time we're replacing one, we want to say logs are added. Cool. And we're also going to be getting them from Lua as well, so we have to make sure to do it there as well. Cool. Now that we have those added there, we can go back to logger.h and let's add some simple macros to get those functions for us. So up here, might as well do that here. And we can just say define Scion log added. That's just all this. Added. And then reset added. Is that what we called it? Reset added? Reset log added. That makes sense. And then get logs. Get logs. This is just going to be Scion get logs. And clear log. Cool. I think that should work. Everything seems happy. Let's do a quick build just to make sure. Cool. Seems happy so far. Still adding logs. Cool. Now we're not actually resetting anything, so log added has never been, or log reset never been called, but that's fine. We'll get to that. So now we can go back to our log display and start filling out these functions. So right here for get logs, we want to actually go if Scion log added. We only want to get new logs if there's been a log added. Okay. First thing we're going to do is actually call the clear function. And that's the clear function for this, and we'll get to that clear function shortly. And then we actually want to grab the logs in reverse view. We want to get them reverse order from the way that they're in the vector. So we can use an std ranges. Oh, it's being weird. Ranges reverse view. We'll say r logs. And stay on the same line. Scion get logs. Okay, it doesn't like that. That's fine. And then we can say for const auto reference log in r logs. We want to go int old text size is equal to m text buffer dot size and m text buffer dot append because we want to append the buffer of log dot, do we call them logs dot c string. So this is getting each log and it's a log entry. So we need to go really quick and see what we call those. So in logger, where's our log entries? Yeah, so it's log.log. Cool. Back to the display. Log.log. Why is it not seeing this? See ranges. Seeing the include. Weird. Anyway, we'll just keep going. I must be missing something. Oh, I do know what I'm missing. Sorry, guys. Let's go to our CMake text. CMake list. Oh, not for the logo one, not that one. Right. Let's go back in here. Go to the editor. And make sure that our log display.cpp is there, and then our CMake is caught up. Everything seems happy now. So, all right, maybe not. So where is that? Oh, it's an editor displays. Log display. There we go. Ah, yes. See that right there? So it's expanding and it has that semicolon. That's going to cause problems. So let's go back into our logger.h and remove all these semicolons. Cool. Because that's basically just adds it in for us. So if we don't give it the semicolon, then we have to add it. All right, so let's quickly run this again. Actually, no, we'll just finish this first and then we'll run it and then fix any errors that may have caused. Cool. Yeah, because basically all the macro does is it takes whatever's there and plugs it in. So if we have a semicolon there, it's going to plug that semicolon in as well. So let's go back into our log display. Cool, that's happy now. This doesn't need to be there. This AD, yeah, cool. All right, now we're happy. I'm still getting used to using CMake daily for my job. We just use the solution file. So everything's, I'm just so used to using the solution, but eventually I'll be 100% with CMake, so that's great. Okay, so now that we've appended our buffer, we actually want to also adjust our offsets. And we need to go m text offsets dot pushback dot push back, and we're going to say hold text size +1. Cool. And then down here, we're just going to say Scion reset added. Cool. And that's it for get log. So what happens here is every time that a new log is added, we clear the logs that are there, re-grab all the logs, and then add them to the text buffer in a reverse order. Okay, so here, basically all I want to do here is just say MB auto scroll is true. Cool. So for the clear, all for the clear that we do is M text buffer clear and M text offsets. Dot clear. Cool. All right. So now the meat and potatoes is the draw function. So all we need to do for this one is go if not ImGui begin. And we're just going to call this logs. Not begin, we're just going to want to end. So ImGui end, then return. And then I like to put ImGui end right away, because if we get to here, we still have to call it. All right. So the first thing we do every iteration is go get log. So what it'll do is repopulate all the logs for us into our text buffer. So to grab any logs, if there's any new ones added, and then add them into our text buffer and adjust the offsets. Okay. And then we're going to add a button in for clearing. So ImGui, same line. And I'm going to say if ImGui button. And this is just going to be clear. If we are clearing, we call our clear function. And then we also call Scion clear logs. That will actually clear all the logs that we actually have. Then we can say the same line again. Copy this, paste. And then you can actually put in a copy. ImGui comes with a built-in copy to clipboard, and it actually works. It'll copy it to your clipboard. You can just paste your logs wherever you want. So you can go if ImGui button copy. If we're copying, we're just going to want to call ImGui log to clipboard. And then ImGui, same line. And we'll put in a separator, ImGui separator. Cool. And let's begin our child. So ImGui begin child. And we can call this, just say scrolling. And say I am back to 0.f, 0.f. False, we have no flags, no child flags, but I do have a window flag, and it's ImGui window flags horizontal scroll bar. Because some of the logs may not fit, so you might want to scroll over horizontally. And now we're going to push a style, and we're going to use for the item spacing. I'm going to say ImGui push style bar. That's ImGui style bar item spacing, and that's going to be an IM back to 0.f, 0.f. Cool. And then we're going to need the ImGui list clipper. We'll just call this the clipper. So if you just read over this, it says you manually clip large lists of items if you have lots of evenly spaced items and you have random access to the list. You can perform coarse clipping based on the visibility and only submit items that are in view. The clipper calculates the range of visible items and advance the cursor to compensate the non-visible items we have skipped. And we'll be using the clipper right here. So the first thing we're going to want to do is go clipper dot begin. I'm going to say m text offsets dot size. And then we're going to say while clipper dot step. So it steps and it's going to return true if the step is good. But while it's returning true, then keep doing everything inside. Then we're going to go for int line no to clipper dot display start line number less than clipper dot display end line number plus plus. Then we're going to say const char pointer line start m text buffer begin plus m text offsets at line number -1. Then we'll have line end, it's const char pointer line end is equal to line number +1 is greater than m text offsets dot size. And then we're going to set it m text buffer begin plus m text offsets at line number +1 -1. Else m text buffer add. And now we can make a string because we have a line start and a line end. We can make a string from that. We can go std string text. I don't know why it does that right away, but that's okay. Line start, line end. So now that we have our text, we're going to want to change the color based on the type of message that it is. Okay, so the name. So what we want to do is go if text.find info is not equal to std string end pause. Then we're going to want to set the color to, so let's first create a color variable. ImVec4 color, and we'll just have this default to white. Cool. And if it's info, it'll be green. So we'll go color is equal to ImVec4 0.f. Okay, it's pissing me off. 0.f, 1.f, 0.f, 1.f. And we'll make 4 of these or 3 of these. So if it is info, or if it is error, if it's error, we're going to make it red. 1, this 0. Or let's put an else here. Oh. Warning, we'll make it yellow. And then now let's push our style color. So we go ImGui, push, style color, ImGui, call, text, and it's going to be the color. Then we're going to do the ImGui, text, unformatted, line start, line end. Then ImGui, pop, style color. Okay. So yeah, the only reason we use this string is so we can use the find. Otherwise, this is not really necessary because text unformatted does everything that we need from the text buffer with the text offsets. Okay, cool. All right, so we're almost done. Then we want to go outside here. We want to go flipper.end. Then ImGui pop style var, because we added that style variable or var above up here. So we want to pop it off. Anytime you push, you want to pop it off with ImGui. Anything you push or anything you begin. So like anytime it's like a begin child, you want to end child or something like that, right? So speaking of which, we should do that now. ImGui end child. And then we want to say if MB auto scroll, and it will be for now. ImGui get scroll Y is greater than equal to ImGui get scroll Y max. Then we're going to go ImGui set scroll Y here 1.f. Cool. All right, KD, and I think we're good. I think we're good. Now let's go add this into our application. So we're gonna have to make a few changes in our application as well. So if we go to Scion Editor, go to application.cpp, and we'll go to our displays. We have our scene display here. Let's add our log display. Log display. And because both of these already have iDisplay in it, we'll have the ability to get the display folder, which will hold all our displays for us. And right now, where are we creating our displays? Do we have, let's go to .h. Yeah, so we're not doing anything for displays. Let's get rid of this for now. And we can say, let's add another one. We'll go bool create displays. Got to be careful when I hit that button. Oh, it did it. All right. So sometimes it works, sometimes it doesn't. So where's our scene display? Scene display right here. And that's being done. That's getting it. Where are we creating it? Scene display. 3. Right here. So we actually want to remove this from the initialize. Let's take, yeah. So let's take all of this out. Cool. and go to our new create displays. Create displays. We'll just paste it in here for now. But we're not going to want to use the regular registry for this. I'm going to want to use the new main registry. Okay. Now, I didn't go over that, but what I ended up doing, I don't know if I went over that or not, but I'll quickly go over it anyway. So here in our Scion core ECS, I ended up making a new main registry. The main registry will hold on to things that only need one registry. Because eventually we may need other registries, multiple registries for different entities and stuff like that. Different scenes will have its own registry, or you might need more than one registry. However, we'll only need one main registry, and that's just a singleton class that I created that has, basically it will have your asset manager, your music player, and stuff like that. But it looks like I didn't make some other changes that we have to quickly make here. So in our main registry, right now, I'm going to have to make a few changes. So let's go include registry. And then down here, we're going to have to add a few things here. Just this. Let's get rid of, this doesn't need to be here anymore because we're actually including the registry file. So we should have a main registry.cpp as well. So source, main registry. This won't be needed in here. Let's actually just take this from here and put it here like that. I like that better. We're also going to need to be able to add context, to bring context to the main registry. Because this is in the core, it's not part of the editor, but there's certain editor specific stuff I'm going to want to add to the main registry. So we're going to need to be able to add to the context of the registry as well, okay? Being in the core, it could also be not just only for the editor, but eventually we're going to have a Scion runtime, and the runtime won't have a lot of the editor stuff. Like there'll be no displays. The runtime will actually just run the game by itself. But we're pretty far out from that, but eventually we'll get there as well. So let's add in the template function. So we can go template, and it's type name, T context. Basically, it's just a wrapper for the already add context and get context functions that we already had. So T context, text, add to context, T context, context. And this is just return MP main registry, add to context, P context. Yeah, so all these are going to be our wrappers, like wrapper functions, and we'll just copy all this. This will just get context. Doesn't need this. Cool. That should all work. So let's go back into our application. And first thing, let's get the main registry. So we go auto reference main registry is equal to main registry. I made a macro for that. So just get us the instance. So if you highlight this here, Scion core ECS main registry get instance, it returns the main registry. And we're going to want to create a display holder. So we're going to go auto p display holder is equal to std make shared display holder. Cool. Then we want to add the display holder to the context. So if not main registry, add to context, std shared pointer display holder, and that takes in p display holder, Scion error, failed to add the display holder to the registry, to the main registry. Cool. And then just return false, because this is going to be called in our initialization. So it shouldn't go any further if it doesn't work. Return false. Cool. All right, then we still have our scene display. And for now, we can just leave this registry being sent in, but we're gonna have to fix that eventually. But we don't want to add it to this context. We want to add it to the main registry's context. Actually, we don't even want to add it to the context. We can get rid of this here. And let's create another display. That's going to be our log display. Log display. And then we want to go, log display doesn't take any of this. And we can take this here, log display. Cool. Fail to create log display. Fail to create scene display. Cool. And once we have our log displays, but these don't want to be shared anymore because I changed how the display folder holds them. They're going to be unique. So this can be unique. We don't need to share them. And then we can say to do, create, and add other displays as needed. Cool. So once we have these displays as well, all we need to do is add them into our display holder. So we can just say p display holder displays pushback std move. Then we want to say p scene display. And we want to copy this line down and just do the log display as well. P logs. Cool. True. All right. Cool. Almost there. So now, where do we remove all that stuff? So in our initialize, down here, we can create our displays. So right before we create our fonts here, might as well just create our displays. So if we go if not create displays, we can go Scion error failed to create display. Return. Well, go to our create displays real fast. I think I put return true at the bottom. I just want to make sure. Yep. Cool. So now if we go to, I believe we called it render ImGui. So right here, we're creating our dock. We're probably going to have to adjust this slightly here. So we have our center node, which is going to be our scene. It's going to have our scene on it. So we're going to have to split again. Let's try this. Let's say const auto log node ID is equal to ImGui dock builder split node. And we're going to want to split it on the center node. Dear. Down, top, so up, let's say down. And then we'll split it 0.2. Null pointer. Center node ID. Top window. Log node. Right. Cool. We'll see what happens there. This has to be sent in as a pointer. Cool. And we no longer need to do this here. We're going to get rid of this. And are we sending in our main? Let's get our main. So the first thing I'm going to want to do is go auto reference main registry is equal to main registry. Then we go auto reference display holder. We can say p display holder is equal to main. registry, get context, std paired pointer of display folder. Now it should be there. I'm not going to add a check-in right now for that. Oh, we're not happy about something. That needs to be a reference. Let's go back. Cool. Then we want to say for const auto reference p display. So for each display in display holders, displays, display holder, p display holder, displays, we're going to want to call the draw function. So p display. Cool. That's it. I think that should work. I'm not sure if we're missing anything. We probably are, but we'll see. Let's try to run it. All right, so it looks like it made our logs. It didn't add it in. Oh, but it did log. That's exactly what I wanted to see. Cool. So we can just dock this here. I wanted it to build it, put it there, but it didn't do it on its own. Why? Oh, logs. Let's see what it does now. Cool. Oh, I wonder if it did that on its own. Let's just pull it off and close it and run it again. See if it put it back there. Cool, it does. That was a great guess. So this is down here. We can change the size. So that was 0.3. Let's change this. Oh wait, no, did I change it to? I had it as 0.2. Let's put it to 0.3 F. Okay, 0.3 is a bit too big. Let's go 0.25. And yeah, just play with it. You know what I mean? So basically, the dock builder allows you to have default docking value of docking windows for whenever you start. So you're not relying on the perfect. I like it. Cool. So there we go. So it's logging all there. We can clear it. Cool. It worked. Let's run it. See, yep, we got some errors. That's what I like to see. All right. It's exactly what we wanted to see. All right. Now we can copy it. Let's open up Notepad here. So I have it right now copied and paste. Cool. All our stuff is there. Don't save. All right. That's it for this video. So we were able to get the logger. Actually, hold on. Before we finish up, we're still making this pop up. Now, what we can do is we can, in Windows, we can hide this right off the hop. Right now, we're just going to keep it. But eventually, what we're going to want to do is in our main.cpp here, you're going to want to put something in right as soon as you start up that will hide it for you. So we can just do something like that. So if not def and debug and debug else and div. Cool. And then you can go to do show console via OS, like whatever your OS system is. And then here, this will be hide console via OS. Okay. And we'll get into that in the next video, but that's enough for now. Right now, we're logging to a new log display. And in the next video, we're actually going to work on projectiles and getting our players to shoot projectiles and adding sounds for the jumps and stuff like that. Please like and subscribe if you haven't already. If you have any questions or concerns, leave a comment below and I'll make sure to get back to you. All right, take it easy.